Prasanna from Christ University. Today I'm going to present my project, the Samsung Innovation Campus capstone project. This is basically diecast predictor. So what does this project do is, so it analyzes the weather patterns through the images which is given by the user. So this project, what made this project different is, so I have introduced the Keras model. So it's basically a local LLM kind of thing, which will be running in the app. So whenever the user installs or access this app through the web application, the model will be working locally. So they can utilize the particular app anytime when they are required. So we'll go through the particular stages through which I have done this project. So here, let's see the difference. What does basically make this app different from the other apps? So here in traditional apps, so we'll be having a rigid interface, so which it does not deliver the particular predictions correctly, and it does not provide any suggestions. So what I made is I have introduced a new version of GUI, which is more interactive. So and I integrated Gemini LLMs through which it can provide detailed description about my models and the prediction rates. So and then lack of sensory immersions. So this is basically whenever the data has been delivered by the model, it is not accurate. The model will be delivering the particular prediction rate with the misconceptions. So I have overcome with this through this Keras model. And then this is basically the structure in which I have developed. So the particular visionary ingestions. So this is basically the photos which will be given by the cameras, or the user can upload the particular images. Sensory feedback. So sensory feedback is basically the working part of my project. So where we'll be having the Keras model pipeline. So I used Flask and Fast API at the backend, and then TensorFlow models to communicate. So and I'm trying to deploy the model, but the model is quite larger. So it's basically 250 MBs. So I can't deploy it freely. So I've used cloud thread and Flutter models to localize the model, and then real-time vision processing. So vision processing is basically you'll be passing the particular images to the model through the cameras and then uploading files. And then intelligence and hybrid architecture. At first, I mentioned that I have developed a model in a right way that it can work at any time whenever the user requires. This is basically the hybrid architecture which I have developed here. So and I use Google Gemini to create the descriptions. And then in the traditional apps, so the particular ambience and the mood of the apps does not change, it's rigid. So but my app could play songs based on the weathers. So here I will be providing the SQLite database for the users. They can log in and they can give the corresponding links such as Spotify links or YouTube link, or they can upload their own file. So whenever we upload an image to a particular model, it maps it to the corresponding music, and the music will be played at the backend. So and I have given the link interface, and this is how the workflow. So I've made the model. So I'll show the demo right now how it works. So this is my web application which I developed here. So you can see it's quite neat, and you can get the data through chatbot. So now I'll upload an image over here. So it's
The day begins with a breathtaking sunrise, painting the horizon in soft, luminous hues as the first light breaks through. The atmosphere is calm and filled with the quiet.
So you can get the particular descriptions through Gemini. So I have used voice APIs in the front end, so it can communicate with the user. And you could take the real world images even. So whenever you want, you can upload. So and then over here now it's sunrise, right? So whenever we play listen songs now. So if you want to listen songs, you get this. So I will place the song according to that. So this is my project.